Morning students, this is Arvind, Assistant Professor DBS IIT, Kavali. So in the previous session I discussed about some speed control methods of DC motors, and now I am going to discuss some characteristics of DC motors. Okay, so let's get into the topic. Firstly, we will see what is the main objective of the characteristics, and next we will discuss different types of characteristics in the DC motors. Okay, firstly, characteristics of DC motors. So here, the performance of a DC motor can be judged from its characteristic curves is known as motor characteristics. Okay, the performance of a DC motor can be judged from its characteristic curves is known as motor characteristics. So DC motors are either shunt, series or compound motor. So I already said that in the types of DC motors we have different types like separately excited and self-excited. In the self-excited we have different types like series, shunt, compound motors. So here DC motors are either shunt, series or compound motors. We generally interested in the following three characteristics. Okay, those three are speed, armature current characteristics, and torque, armature current characteristics, and speed, torque characteristics. Okay, the third characteristics, that is speed and torque characteristics. The third characteristics is obtained from the first two characteristics, that is speed and armature current, torque and armature current characteristics. From those two, we have to obtain third characteristic, that is speed torque characteristics. Next, so these are the three characteristics we have, torque and armature current. So in the torque and armature current characteristics, the curve is drawn between armature torque tau A and armature current IA of a DC motor. And coming to the second one, that is speed and armature current characteristics. So in this one, the curve drawn between speed and armature current IA of a DC motor. And next, coming to the third one, so it is the curve drawn between speed and armature torque of a DC motor. So I already said that the third characteristics of the DC motor is obtained from the above two characteristics, that is torque and armature current and speed and armature current characteristics. Okay, so firstly we will go to shunt motor characteristics. So I already said that we have three types of DC motors in the self-excited. Those are series motors, shunt motors, and compound motors. So firstly we will see the shunt motor characteristics. So this is the diagrammatic representation of shunt motor. So if you observe this diagram, the motor consists of armature and field winding, but here the armature winding is connected to the DC motor and the field winding is connected parallel to the armature winding and DC motor, and these two are connected parallel to the supply, DC supply. Okay, so here we have armature current IA and load current IL and shunt field current ISH. Okay, and the shunt field resistance RSH and series field armature resistance RA. So this is the connection diagram of shunt motor. So here the figure shows the connection diagram. So I already said that this diagram. Okay, here the field is connected. So this one RSH, the field is connected across the supply voltage V. Okay, since the supply voltage is constant, so in the shunt motor we will take in as supply voltage is constant, the field current and hence flux are also constant. So field current IF and flux phi is also constant. These two terms are also constant here in the shunt motor. Okay, so coming to the first characteristic, that is speed and armature current characteristic. So in the previous class I discussed about the speed equation of a DC motor. So you already know the equation, that is N is equal to K into V minus IARA by 5. So here in this case, field current, that is shunt field current ISH and flux are nearly constant. Why? Because the supply voltage is constant. That's why here the shunt field current and flux are nearly constant. That's why the equation of the speed is becomes N is equal to K into V minus IARA, where K is constant. So I already said in the previous class. So where K is constant, so this implies that speed is nearly constant except for a small drop. So if you observe this characteristic diagram, so here the characteristic diagram is drawn between speed N versus armature current IA. So the armature current is taken in the x-axis and speed N is taken in the y-axis. The dotted lines in the figure indicates the base speed of the. So here the speed is nearly constant except for a small drop. So actually up to some point the speed is constant. But if you observe a small drop, little bit drop, so it the speed is decreases into a small manner. So this is the characteristic diagram, first characteristic diagram of a DC shunt motor, that is speed and armature current characteristics. Okay, and next, due to these characteristics, the DC shunt motor acts as a constant speed motor. Okay, due to these characteristics, the DC shunt motor acts as a constant speed motor. So I already said that the speed is nearly constant except for a small drop. That's why this DC shunt motor is a constant speed motor. So the main applications of DC shunt motor are machine tools, lathes, driving shafting, woodworking machines, and for all other purposes where constant speed is needed. So whenever we want the constant, we are using the constant speed. At that time, we use this DC shunt motor. Okay. Next one, torque armature current characteristics. So previously we discussed about speed armature current characteristics. Next, torque armature current characteristics. So here the curve is drawn between torque versus armature current. Torque versus armature current. The characteristic diagram is drawn between these two. So here we have two torques. So I already discussed in the torque equation of a DC motor. We have armature torque, that is the main torque, and we have one motor, that is the shaft torque or useful torque. So here the vertical line, that is a gives the vertical thick line gives the armature torque, and this dotted lines curve gives the shaft torque. Okay, so TA and TSH. So coming to this one, torque armature current characteristics. So these characteristics are also called as electrical characteristics. Okay, torque armature current characteristics is also called electrical characteristics. So here the DC shunt motor torque, the DC shunt motor torque, that is tau, is directly proportional to flux and armature current. So I already discussed this one in the torque equation of a DC motor, and in the previous class, that is the speed control of DC motor also, I discussed this point. Torque is proportional to product of flux and armature current. So here flux is constant. That's why we have torque is proportional to armature current only. So when the armature current increases, the torque also increases. Why? Because here the armature current is directly proportional to the torque. Okay, next, the dotted line is indicated as a shaft torque here. So if you observe this diagram, so here the dotted line is indicated with the dotted lines gives the shaft torque curve. Next, coming to the speed torque characteristics. Speed torque characteristics. So here it is also called mechanical characteristics. Okay, it is also called mechanical characteristics. So previously we discussed torque versus armature current. Those characteristics are called electrical characteristics, and now this characteristic speed torque characteristics is also called mechanical characteristics. So these characteristics can be got from the above two characteristics, that is speed armature current characteristics, torque armature current characteristics. Depending upon those two characteristics, we will obtain this characteristic. So here, when the load torque increases, so this one. So if you observe this diagram, it is the curve is drawn between speed and torque. So here the torque is taken on x-axis and speed is taken on y-axis. So here this is the curve of the speed torque characteristics. So here when the load torque increases, the speed slightly decreases. So if you observe this line, so when the load torque increases, the speed slightly decreases. Up to some point it is a straight line. So whenever the load torque increases, the so this one, some drop is there. So it is indicated in this figure. Okay, this is the speed torque characteristics of a DC shunt motor. And next, coming to the DC series motor characteristics. So up to now we discussed about DC shunt motor characteristics, and now we are going to discuss DC series motor characteristics. So this is the connection diagram for a DC series motor. So in this diagram, the motor consists of both armature winding and field winding. Both are in series with the motor, and it is connected across the load. Okay, so here the field winding and armature field current and armature field winding and armature winding are in series. Okay, that's why here the armature current IA is equal to series field current ISC, that is equal to load current IL. So here all the currents are same because of this is a series connection. So in the series connection, all currents are same. That is IL is equal to IA is equal to ISC. So here IL is equal to load current, IA is equal to armature current, ISC is equal to series field current. Okay. Next, coming to the first characteristic, that is speed armature current characteristics. In this one, as the flux depends on the field current, that is ISC, because of this is a series motor. So here the flux depends on the field current ISC, which is same as the line current. So I actually said that in the previously, here for a DC series motor, load current IL is equal to series field current ISC, that is equal to IA, armature current. So here, as the flux depends on the field current ISC, so which is same as the line current, that is IL, the flux is not constant with the loads. Actually, the flux is not constant with the loads. That means the speed equation is n is equal to, already, n is equal to k into V minus IRA by 5. It becomes n is equal to k into y, because here the flux is equal to the field current or armature current. That's why in the place of flux, I am replacing armature current. Okay, so that is n is equal to k into V minus IARA by IA. So you already know that back EMF EB is equal to V minus IARA. You already know this point. So from this one, I am replacing V minus IARA with EB. So the equation, the speed equation becomes n is equal to EB by IA. So from the above equation, it is clear that by increasing the armature current, speed is decreases. Why? Because here the armature current is inversely proportional to the speed. That's why whenever we increase the armature current, speed will decrease. Okay. Next, coming to the diagram, characteristic diagram of a speed armature current characteristics. So here this is the diagram. Here the curve is drawn between speed and armature current. Okay, here armature current is taken on x-axis and speed is taken on y-axis. So here the curve is like this. So actually it is in the base point, that is the increasing manner, but whenever the armature current increases, speed decreases. So like this we have. Okay, this is the curve. So I already said that by increasing the armature current, speed will decrease. So depending upon this one, this curve is drawn. So whenever the armature current increases, the speed is decreases. Okay, this is the curve of the speed armature current characteristics of DC series motor. And coming to DC series motor, should never be started without some load. Should never be started without some load. So series motor will start with some load. So otherwise the motor speed will rise to a dangerous value and get damaged. So if the series motor is not started without some load, the motor speed will rise to a dangerous value and get damaged. So for this reason, the series motor will start with some load. Okay. And next, you already know the torque armature current characteristics. So up to now we discussed about speed and armature current characteristics, and now we are coming to torque armature current characteristics. So we already know that torque is proportional to the flux and armature current. So in DC series motor, flux is directly proportional to armature current. Okay, that's why I am taking phi is proportional to IA. So you already know that tau is proportional to phi into IA. So in the phi place, in the flux place, I am replacing IA. So that's why we have torque is proportional to IA into IA, that is IA square, that is before saturation. And after saturation, the armature current, the flux is constant, and now we have only armature current, that is tau is proportional to IA, that is after saturation. So at light load, armature current IA and hence flux is small. At light load, armature current IA and flux phi is small, but as IA increases, tau A increases as a square of the current. Okay, but as armature current increases means torque increases as the square of the current. Hence, this characteristic is a parabola. So this is a parabola. So if you observe this diagram, the curve is drawn between torque and armature current. So here armature current is taken on x-axis and torque is taken on y-axis. So if you observe this curve, so we have torque is proportional to Ia square up to some point, and after saturation we have torque is proportional to Ia. So before saturation we have torque is equal to Ia square, and after saturation we have torque is equal to Ia. Okay, this is the diagram, characteristic diagram for torque and armature current characteristics for a DC series motor. Okay, next we have, so it is shown in the figure. So if you observe this diagram, this is the diagram for the torque armature current characteristics. So after saturation, the flux is constant. So I had said that torque is proportional to flux and armature current. Okay, but after saturation, the flux is constant, and the equation becomes torque is equal to Ia only. So after saturation, the flux is constant. That means phi is independent of Ia. Hence, torque tau A is proportional to Ia. So the curve becomes a straight line. So before saturation, the curve is like this, and after saturation, it becomes a straight line. Okay, that is the parabola. Okay, this is the characteristic diagram for a DC series motor. That is torque and armature current characteristics. And next, coming to the speed torque characteristics. So this characteristics can be got from the above two characteristics, that is speed armature current, torque armature current characteristics. We obtained this characteristic. So here the DC series motor speed is high. The DC series motor speed is high. The torque is low and vice versa. Okay, the DC series motor speed is high, the torque is low. So it is shown in the figure. So if you observe this diagram, okay, here the curve is drawn between speed and torque. So here in this case, the torque is taken on x-axis and speed is taken on y-axis. So if the torque is increasing, the speed is decreasing. Okay, the speed is decreasing. So this is the characteristic diagram for a speed torque for a DC series motor. And next, coming to compound motor characteristics. Compound motor characteristics. So here the characteristics of a DC compound motor will depend on whether the series and shunt field windings are assisting each other or opposing each other. So here we have two cases. So actually in a DC compound motor we have two types of motors. One is long shunt compound motor and another one is short shunt compound motor. So here we are taking both series and shunt field windings. Okay, so here the characteristics of DC compound motor will depend on whether the series and shunt field windings are assisting each other. That means helping each other or opposing each other. That means differential. That is the difference. Okay, assisting means cumulative, opposing means differential. So by taking the cumulative connections, that means assisting each other, both the series and shunt field windings are assisting each other. The characteristics will be between those of shunt and series motors, whereas for the latter they tend towards those of the series motor. Okay, so in the cumulative connection the characteristics will be between those of shunt and series motors, whereas for the latter they tend towards those of series motor. Okay, so if you see the diagram you will understand. So here the characteristics are shown in the figure. So if you observe this diagram, the curve is drawn between speed versus armature current. The speed is taken on y-axis and armature current is taken on x-axis. So here we have four curves. Okay, here we have four curves. One is for shunt motor and another one is for series, and we have two more curves. So here the number is indicated with the 2. So that curve 2 corresponds to the cumulative and curve 3 to the differential connection. Okay, that is curve 2 means it is assisting each other. The series and shunt field windings are assisting each other. The curve is like this, and the series and shunt field windings are opposing each other. It is indicated in the third curve, that is number 3. Okay, so this is the characteristic curve for a compound motor. And next, coming to these two. So here also we have speed and armature current and speed and armature current characteristics. So if you observe this, we have different characteristics, shunt series and curve series. Also we have, if you have the armature current increases means speed decreases. Okay, and next in the shunt winding, so in the shunt motor, so the speed is slightly decreases, and in the series motor also the armature current increases means the speed is decreases. And coming to the differential compound motor, so that is here the series and shunt field windings are both are opposing each other. That means the speed is decreases. Okay. And next, in the second curve, that is the series and field windings are assisting each other, that is helping each other, that is a cumulative connection. The speed is increases. Okay. And coming to the second diagram, on the left side, on the right side, we have the curve is drawn between speed and armature current. Here also we have four curves. Two is for series and shunt, and two is for cumulative and differential compound motors. So here, the armature current increases means the speed is increases. Okay, both for the shunt and series and cumulative and differential motors, we have this characteristic diagram. Okay, so these are the characteristics of a DC motor. For a DC shunt motor, for a DC series motor, and for a DC compound motor, we have three types of DC characteristics, that is speed, armature current, torque, armature current, and speed, torque characteristics we have. These are the characteristics. Okay, thank you. In the next class, we will discuss necessity of starter and 3-point starter, 4-point starter, and next difference between 3-point and 4-point starter we will discuss in the next class. Okay, thank you.